right, everybody. I'm going to try this again. Again, this is take 2 of today's August 8th office hours. Probably lost most of the audience there since this is unfortunately via a different link than the original session, but just give me a moment here. I'm actually in a text chain with Xfinity, but I'm going to stay in this because it looks like it might be working right now. Just hold on for a minute here. Okay, I am negotiating with the inbound utility crews as to when they cut the connection off to try and troubleshoot the problem. So this will probably be an abbreviated session, and I'll know just how abbreviated it will be momentarily when they get back to me to tell me when that tech team arrives. Somehow I've managed to stumble into the special tier of Xfinity customer service where the service and the crews can actually respond within an hour. That may come with some degree of social media notoriety and fear of bad reviews. So anyway, something constructive. Okay, so I've got about 20 to 25 minutes and no more, so this will be an abbreviated session, but looks like for the moment the problem is solved. By the way, last time the likely culprit was supposedly squirrels. This time it is water in the form of drizzle here in Boulder, Colorado, where we are receiving some significant, well, aggressive drizzle, I guess you'd call it, following what was by far the driest period on record in Boulder and along the Colorado Rocky Mountain Front Range since early April. So much needed, although apparently it's a problem for our telecommunications infrastructure if it gets wet. I'll leave it at that for now. Anyway, thanks for those who have come back. I suspect that some folks will probably trickle in over the next 5 or 10 minutes, although I still think most folks probably, understandably, I don't blame them, gave up after the first 5-minute version was almost unintelligible. So I'm going to cut to the chase. Thanks for joining this take 2 of the live session. I almost said this Friday, but it is in fact not Friday, though it might feel like it is. And I wanted to talk today partly because there isn't anything extreme or horrible that's new in many ways to talk about in California right now. That's sometimes it's nice to have these conversations when there isn't some actively unfolding disaster. Now, to be clear, there are still at least 2 major wildfires burning right now. One of them, of course, being the Park Fire, which is continuing to burn upslope pretty aggressively. This was a fire that was really had calmed down about a week ago amid quieter, cooler, moister, and cloudier weather conditions, but then really took off again on its northeastern flank in the recent days, resulting in some new evacuations and in a number of what appear to be close calls for firefighters on the northeastern flank of this fire, including some ambiguously reported burnover events. Fortunately, it doesn't appear that there were serious injuries as a result, but it's a testament that this fire was jumping fire breaks that were 10 or 12 dozer blades wide, meaning the width of 10 to 12 firefighting bulldozers, which are exceptionally large bulldozers as far as they come. So that's a pretty substantial distance for a fire to jump, especially given that we're not talking about a particularly wind-driven fire. If we had 70-mile-an-hour winds as we had during the Camp Fire or the Tubbs Fire or the Woolsey Fire or any number of other major wind-driven catastrophes in California in recent years, it would not be that surprising to see a fire jump a 10 or 12 dozer blade fire break. In fact, we've seen those kinds of fires jump rivers and 8-lane freeways on multiple occasions. But we do not have those sorts of winds, and we haven't for any part of the Park Fire. Winds have not been much above about 30 miles per hour over the fire zone broadly, with locally stronger winds up to 40, 50 miles an hour when the fire was producing fire vortices and pyrocumulonimbus clouds. But generally, the ambient winds have only been modest, light to moderate winds, generally upslope, 10 to 20 miles an hour, gusts occasionally to 30. But that is not an unusual level of wind for August in this part of the state. And yet this fire has been aggressively jumping some of these fire lines and highways. Part of the reason is that the vegetation that it's now burning in, this is no longer a fire that's primarily burning in grass and brush at lower elevations. That part of the fire is largely inactive at this point and contained, but the part that's very active and still aggressively burning to the north and east is burning in very heavy timber. So these are fuels that have not burned in a long time. They're very dense. The topography is very favorable for upslope runs and wind channeling, and so even pretty light winds in the context of very heavy fuels, difficult access and topography, as well as, of course, we have to talk about it, the legacy of that record-breaking heat throughout the month of July, that kiln dried a lot of these fuels. They would be even drier than they are now, though, had we not had a wet winter, or 2 wet winters in a row, by the way. So if this were occurring in the context of a severe drought, I don't even want to think about what the fire behavior would be looking like on this northeastern flank of the park fire. So it could have been worse, or if we had stronger winds, that could be a lot worse as well. But what we did have was 2 consecutive wet winters, and then a record hot July. And speaking of that record hot July, we do have plenty of initial indications that July will probably turn out to be the hottest on record on a statewide basis. I've looked at some of the preliminary data. It was certainly the hottest on record for the southeastern deserts, which is, of course, that is a very hot region in July, so that is saying quite a lot. Also the hottest on record in the Sierra Nevada foothills and the Coast Range foothills ringing the Sacramento Valley. So really the entirety of that 1,000 to 3,000 foot elevation band, almost 360-degree arc surrounding the Central Valley, was definitely the hottest July on record in those areas. It was a number 2 or number 3 ranked hot year nearly everywhere else away from the immediate coast. And in fact, it would have been the hottest July on record virtually everywhere except for the beaches, were it not for the fact that the last week in July was not quite as extremely hot. Although, if you look at a moving 4-week window, so if you include the last week in June and the first 3 weeks in July, then, excuse me here, I think there may be an Xfinity person in person. Let me just double check and see who's here. Oh, no, I guess not. Anyway, someone banging at the door there. You're watching in real time the level of customer service you can get when you have some internet visibility. Anyway, there was a 4-week window there that was probably the warmest 4-week period on record, even though it didn't directly align perfectly with the month of July. Nonetheless, given that probably about half of California saw its hottest July on record and nearly everywhere else saw its second or third hottest July on record, I am betting that when the official NOAA data comes out next week, that it will probably end up that California and Arizona, and possibly Nevada as well, saw their hottest Julys on record. That was, by the way, information that was going to be officially out today, which is part of the reason I scheduled the session for today, but it was delayed. Perhaps NOAA is having some connectivity issues as well. By the way, it looks like I am once again having some connectivity issues on my end too, so I'm going to keep going unless it gets worse, but just in case I drop out again, that would probably be wise. So the park fire remains quite active on its northeastern flank, but the good news is that the current second wave of this 2-peaked heat wave that we talked about last week is nearing its end. So temperatures are now still hot today, but going to be cooling into the weekend and into next week. And in fact, it looks like weather conditions will be pretty calm as we head towards mid-August. So it looks like conditions will be near or even slightly cooler than average. Yes, I said cooler than average for a good chunk of time in mid-August. It may be breezier, so the caveat might be that we now have 2 significant fires. By the way, I didn't mention the other one. One is the Park Fire, which you've been now familiar with for days to weeks. And the other one is a new fire. I don't know if this is supposed to be, I don't know the place name that this was named for, so it's either the Crozier Fire or the Crozier Fire, depending on whether this is a name of French origin. Anyway, this is burning on the western slope of the Sierra foothills, just north of Highway 50, so this is north of Camino. It's already about a 1,500 to 2,000 acre fire, started yesterday, so we didn't see quite the same explosive rate of growth, as we did on the Park Fire in its initial hours. But what we are seeing is that it is nonetheless growing fairly quickly in an area that has more of a wild than urban interface. So there are more people in that region that live in the woods near the fire zone, and it is spreading on, it has 2 distinct heads already, so it is quite active, and it is detracting from some of the firefighting resources that were up on the Park Fire, presumably, so there is competition for resources. It's going to be breezy for the next several days, and so although the heat is fading, the fire risk is going to remain quite high in these regions, and spread on existing fires could remain pretty elevated. So there's a major firefight going on the northeastern flank of the Park Fire. They're trying to hold it at a couple of different highways in and near Mill Creek and Mineral. The fire is in that vicinity right now. The question is, if it jumps those highways to the north, then it's got a lot more room to roam, unfortunately. Still active on parts of its eastern flank, but not moving very quickly. So we'll just have to see how this goes over the weekend. No extreme fire weather, but continued elevated fire weather. So, we're not talking about 95th, 99th percentile conditions, but we're still talking about maybe 80th to 90th percentile conditions, which, given the level of activity we're already seeing, will be enough to keep things going on both of these fires that will continue to pose a risk, given that they're both burning in very heavy fuels, in challenging locations, and following what was, in the regions where the fires are burning, the singularly hottest month on record in July. I'm going to make a not very bold prediction for August, is that it will not be the hottest August on record. In fact, it probably won't even come close, based on what we're seeing right now. I would call it a month that is still likely to be warmer than average in most places, although perhaps not by a particularly large degree. So August will feature definitely a reprieve in the heat in most places relative to July, especially the first half of the month. Even if we see a resurgence in the heat towards the end of August, the middle of the month will probably not be too bad either way. This does not mean that there's going to be any reprieve in the form of, say, rain. In fact, it does look like the next couple of weeks are going to be very quiet from a monsoonal perspective. So right now, not seeing evidence of early season showers in northwestern California with an August trough or anything, nor am I seeing tropical remnant moisture or monsoonal moisture making it into southern and eastern California in any meaningful way. So this will be a genuinely pretty quiet period, where the most notable stuff will probably come from the fact that the breezy conditions, even though conditions may be around average temperature-wise or even slightly cooler than average in some coastal spots, those breezes will keep the fire risk elevated and will keep those fires burning actively upslope in the Sierra, even though I don't expect to see extreme fire danger during the period. So all in all, a fairly quiet period. And just reminding folks who have joined, thanks for coming back, still experiencing some connectivity issues, and Xfinity is going to cut the connection off in about 10 minutes so that they can troubleshoot the problem. So I got about 10 more minutes to talk. I'll talk for about 5 more, and then I'll take about 5 minutes of questions, and that'll probably have to do it for today's abbreviated session, although I'm glad that the connection, at least for this moment, has worked well enough to get this much out. So again, the official NOAA numbers will come out next week. I'll talk about that during a live session at some point next week. How does that sound? A question about, something that I wanted to briefly mention about the autumn outlook. La Nina is likely still coming, although it may not be as strong as some of the initial modeling had suggested. So if that's the case, the implications for winter are less clear, and the tilt towards a drier than average winter might be even weaker. So that could be good. But this fall still looks unusually warm and unusually dry, potentially in California. So a higher than average likelihood of a delayed start to the rainy season and a particularly warm September and October. Given what's come before, I still think that means we will see an extended and potentially severe peak to the fire season in September and October. Just because that's when the vegetation reaches peak seasonal dryness, and even if we see average number and frequency and intensity of offshore wind conditions in autumn, that will combine with vegetation that is at lower elevations, which is where some of these offshore wind-driven fires in the wildland-urban interface are at their most dangerous. Vegetation there is at very dry levels, given the extreme warmth we saw in July, the continued relative warmth we're likely to see the rest of the season, and combine that with the robust herbaceous fuel growth, so grass and brush growth, as I've talked about extensively, from 2 consecutive wet years along the coast. So that does now comport with the official NIFC seasonal outlooks, which I disagreed with when they were issued in spring and called for a below active season across much of the West. Now they call for an almost uniformly above active fire season for the rest of fire season in California, and I think that's likely to be true. Again, a tilt in the odds does not mean any guarantees. As always, if there are no ignitions, there are no fires, although to be quite honest, there are always some ignitions, so it's a question about whether they occur at the wrong place at the wrong time. Park Fire was definitely one example of that. We will just have to see how things unfold in fall. We could still get lucky, you never know, with an early season rain event, although I think the odds are lower even than the usual low odds in autumn. We could also get lucky with either infrequent or weak offshore wind events. Again, I don't see any particular reason to think there's going to be a tilt in either direction. With the wind events, we really don't have seasonal predictability there, but I'm still looking at a pretty significant peak in fire season in parts of, especially the coastal parts of California, that may not come till September or October. All right, so got a few more minutes here. I'm going to take a look at a few questions that have come in. Steve asks about how smoke, presumably mainly from wildfires in the present context, aloft can get mixed down to the surface. What kind of conditions and topology contribute to this, and how can we predict smoke events caused by this? So really, the worst conditions for smoke pollution at the ground from a wildfire are actually not extremely aggressive fire conditions in some cases, because often what will happen then is when you have a plume-dominated fire, meaning that the fire generates so much heat and the atmosphere is sufficiently unstable, it develops into this large pyrocumulus plume. That's bad for fire behavior and for firefighters and people wanting to fight the fire. But it actually means that the ground level air is often a bit cleaner because it ventilates the area right around the fire because there's so much upward motion. It sucks that smoke up and deposits it higher in the atmosphere. So you might have smoky skies, but you might not smell much at the surface. The air you're actually breathing in terms of the particulate matter might not be too bad because most of that is getting lofted high in the atmosphere. On a day when the fire is not spreading as aggressively, though, it doesn't put that smoke as high up into the atmospheric column. It might just sort of go up a few hundred feet or 1,000 feet in the air and then just sort of filter out. Those are days that can be smokier in the absence of a plume. And then you also have conditions where at night often a temperature inversion will develop. So folks who live along the coast and experience the marine layer are familiar with the temperature inversion. That's the top of the marine layer is the top of the inversion being the layer in which temperature is locally increasing with height. And that puts a pretty stable lid on things. When it's only a few thousand feet deep, it means it traps all the smoke in the lowest few thousand feet, and you're breathing it. So we tend to see those that inversion set up in the overnight hours, which is why smoke often gets worse after midnight and stays bad in the morning before gradually lifting out as the depth of that boundary layer increases with the daytime heating. And those turbulent eddies get taller and taller and mix that smoke throughout a deeper layer of the atmosphere. You can also get either wind conditions that are blowing from the fire to you, but weakly. So downslope winds in this case from the park fire. So drainage winds overnight, maybe just 5 or 6 miles an hour, but they allow that smoke to gradually move toward you in the valley, for example, at lower elevations. Since strong winds will tend to mix it out as well. If you have 30, 40 mile an hour winds, terrible for fire spread, but actually, unless you're immediately upwind of the fire, you're not going to get too much smoke because the wind is blowing it away. So a stable atmosphere usually means poor smoke conditions. Light winds usually mean poor smoke conditions. So we've been seeing some more of that in recent days. So we're approaching the moment when Xfinity may turn off the internet. So when, again, I'm probably going to stay on for a few more minutes or until it dies. But if you start seeing the spinning wheel of death in the next few minutes, that's probably going to be it. So I won't be coming back on after that point. So just an alert to folks. So I think, what's interesting about this fire season is it is broadly active across the West. This isn't really localized to certain states. Pretty much every Western state has seen major fire activity so far this season. Right now, it's most concentrated in the West Coast states from Northern California up through Washington and Oregon, into British Columbia, as well as all the way up into the Northwestern Territories and the Yukon in Canada. And Alberta, and then as well, the things are really very active right now in Idaho after a major dry lightning event sparked a bunch of fires earlier this week up there. Western Montana, Colorado tried to get in on the act. I experienced some of those fires myself last week with a sustained period of sometimes record-breaking heat, and again, record-breaking dryness along the Front Range. That has mitigated somewhat locally as well with the precipitation right now here in Boulder that is apparently causing so many internet connectivity problems because our infrastructure cannot tolerate water falling on wires. So this is a bit of a mixed bag. Oregon and Washington remain, and Idaho in particular, remain very active, as do the two major fires in Northern California. Is there an overwhelming number of fires in California right now? No. But the two that are burning are of significant concern, and the Park Fire, I will remind everybody, I believe is now the fourth largest in modern California history, and would be, by a significant margin, the largest in state history, except for all of the other big fires that have happened in the past 5 or 6 years. So if we just go back to 2015, or even 2016 or 2017, this would be the largest fire in California contemporary history. But we've seen so many large fires in that antecedent window that it's only fourth ranked. Now, my ecologist and fire science friends will always offer a reminder that measuring fires solely by the number of acres they burn, by their size of their footprint, is an imperfect metric because it doesn't tell us very much about the characteristics of that fire, nor the balance of harm versus benefits that fire has produced across the landscape. And the Park Fire is actually a very good example of one that has caused both major harm and probably had major benefits, depending on where you are in the fire footprint and which aspect of the fire you're talking about. The vast western swath of the fire that burned mainly grassland and some brush and woodland regimes, so really everything other than denser contiguous forest, this fire was probably net beneficial for the ecosystems in that region in the long run, and will reduce fire risk there for at least a number of years to come. Obviously, the fire in and near Cohasset, where it burned hundreds of structures, including a lot of folks' homes, did a lot of harm to those folks who lost their homes, and also to the people who have now been evacuated, even if their homes survived for multiple consecutive weeks. That's not easy either, although there are many thousands of Californians who have experienced that in recent years. So clearly major tangible harm there. And then you go farther upslope and it continues to be a little bit of a mixed story. Some of these areas really needed to see some fire, and this will have some beneficial long-term risk reduction, ecosystem health boosting effects. But the problem is that some of the fuels were so dense and were so dry, given the record heat wave that came before it, that some of the forests that have burned in this fire probably burned at a sustained high intensity over wide areas in ways that probably will be harmful to the viability of those forests. We all saw what happened with the Dixie Fire and other recent fires, which really, for lack of a better term, sort of nuked the forest in some patches. Again, not uniformly so, but there are some areas where the trees are just gone and they are unlikely to come back in our warming climate as a mature forest within our lifetime. So that is the reality, is that there is a mix. There are going to be patches of forest that see this fire as a restorative event and will probably be healthier in 10 or 20 years than they were before the fire. There are patches of forest that were probably devastated by this fire and won't come back as such. People lost their homes as well. And so I think that's the important context, is that a fire this large covering this much land in a region as diverse ecologically and otherwise as California is going to have a range of different effects depending on what you're talking about. So that 430,000 odd acre footprint doesn't tell you everything you need to know about the impacts. You could have had a 430,000 acre fire that didn't destroy any structures and burned at a pretty low intensity or low to medium intensity with pockets of high intensity, and that would have been a super beneficial event. It would have effectively been a 400,000 acre prescribed fire. And big pieces of this event probably did act in that way. It will have had the same beneficial effects as a large-scale prescribed fire. But because it was not a prescribed fire, it was not planned in advance, prepared for in advance, there then is also the harm to go along with it. The hundreds of structures destroyed, the thousands of people displaced for a long period of time, and also those ecosystems that burned in a way that was not constructive and will probably be harmful in the long run. And I think this is, there are other commentators who have pointed out the diversity of impacts that you can get from a single large fire like this. And I think that sort of spans the range of outcomes that you can get from any fire, from net highly beneficial to, essentially catastrophic. And sometimes those are commingled in the very same event. The Park Fire being a good example of that. Well, glad I was able to get at least through that piece of the monologue before the internet cut out. So I'll keep going for a little bit longer until the signal cuts me off. So, and speaking of acreage burned, this is there's been some interesting studies that have come out this year specifically highlighting other metrics that are more directly related to the negative impacts of wildfire, which is to say, the proportion, the amount of high intensity fire. Again, there are even some ecosystems that actually benefit from high intensity fire. But usually at a certain frequency and over certain areas. So in certain forested regimes, for example, it's beneficial to have patches of high intensity fire because it actually results in better habitats for certain species as those trees go away and as those areas become unshaded. New vegetation grows. These can become meadows, for example, in a forest. But the problem is when you have a 50, 100, 200, 500,000 acre contiguous region of very high intensity fire, as has been the case up some of the recent fires, for example, in Canada and some fires in the western U.S. in recent years, that becomes a bit of a monolith of high intensity, and you don't have that diversity, that patchwork of fire intensity in the same way. And again, it's not to say that all fires are burning at extremely high intensity uniformly, but we now have a lot of data. This just came out this year, in fact, from a global satellite survey of fires over the past few decades, which shows that outside of the tropics, and again, the tropics have a very different fire regime than everywhere else on Earth, outside of the tropics, the intensity of fires, particularly of forest fires, has greatly increased. So both the frequency and extent of extremely intense wildfire outside of the tropics has now been confirmed to have increased in recent years. And this was something that had been pretty obviously true anecdotally until somewhat recently, but it had been really difficult to prove at scale with cold, hard data. And now that's been done. So I think it's now safe to say that we are seeing more intense wildfires, especially because of a warming climate, but also in other regions, an additional aggravating factor too that can play into the intensity of these fires through vegetation and fuel density is these historic management practices. So the removal of natural and cultural burning from lands is part of that in places where that occurred as well. But the key is we're also seeing this increase in fire intensity in places where we didn't have those historical practices, where there was not as much of a practice of historical fire exclusion. In those places too, we still see an increase in the intensity of these fires. So clearly there's something else going on, and that something else is climate change. So it's never the only factor at play, but increasingly it is a dominant one because it's operating across space and time, different regions across different fire regimes. And we now have more and more observational confirmation that that's actually the case, rather than just being a highly informed anecdote. Because a lot of our historical data came from the fact that fires were dramatically increasing in size and in destructiveness. But destructiveness is not necessarily very correlated with size. In fact, destructiveness in terms of the structures burned, you can have a 2,000-acre fire like the Oakland Hills fire in the early 90s that burns thousands of structures, and a 1,000,000-acre fire up in the wilderness that doesn't burn any. So size, of course, an imperfect analog for impacts generally, but especially for damage and structure loss. But when we start saying, okay, we're seeing much larger fires, that's telling us something. Because even though this is the combined legacy of a variety of things, we have more aggressive firefighting and more effective firefighting in a lot of ways than we ever did previously, and yet we're still seeing larger fires in some places where we choose to aggressively fight them. That still tells us that something is changing, despite our better efforts to extinguish fires as fast as possible. Whether that's always a good thing or not is seriously debatable, but the fact is that is how things have gone. So not only are we seeing the larger fires, which we knew had some physical links to climate, in fact, some exponential links to things like vegetation aridity and atmospheric dryness, the expanding atmospheric sponge effect that I've talked about before. But we now also have that confirmation that the fires are in fact becoming more intense. And how do we measure that? What does that mean? It literally means if you multiply the area of the fire times the thermal intensity, so the satellite-derived temperature of these fires. They are burning essentially much hotter over larger areas. Is a pretty direct measurement of the intensity of those fires, which is a combination both of the amount of fuel that's available and the dryness of the fuel that is in those settings. So interesting science coming out, concerning science coming out, because it's sort of getting rid of the last possible argument that we could be making at this point, which is that, well, we're seeing larger fires, but they aren't really getting more intense. Well, unfortunately, we can rule that out, and we do now know that the increase in fire size in a lot of these regions does actually correspond with an increase similarly in their intensity, and therein lies the problem. It's not so much that we were seeing larger fires as the problem in itself, but it turns out that the anecdote that these larger fires are on average having a much larger intense component to them turns out to be true, and that's really where the big concern lies in a lot of these settings. So I think I better not tempt fate. We're past the time when they told me they were going to shut the internet off to fix it, even though, ironically, it seems to be working very well right now. So I will probably call it a day here now, but I just wanted to thank everyone for rejoining. I think it almost looks like we gained more folks with the second version of this conversation than were here at the beginning of the first iteration when the connection went down. So thanks for joining. Good to see everybody. As folks have mentioned, it is, as much as it's weird to say, it is very helpful for folks if folks subscribe to the channel. The bonus is you'll be notified when I have these live sessions, including when I have to restart them when there's a connectivity problem. Liking the videos is also something that is helpful that you can do. A reminder that this channel is sponsored by Reask, a company that's rethinking Earth system risk. And if you're interested, you can follow the link that I'll post in the end screen of the recorded version of this video. So I'll have another conversation at some point next week, time TBD. And for now, thanks everybody, and talk to you next time.